Hello everybody and welcome back. Good to talk to all of you again today, and today we're going to be talking about the OceanGate Titan, the deep sea submersible that's taking 5 people down to the Titanic and that is currently lost. And there's a pretty major search and rescue effort that is currently looking for them. Now, my personal interest in this is actually kind of interesting actually. This company had actually come to my school like 2 months ago, I think, relatively speaking, to try to find an intern to go out on this expedition. And at the time, I actually really wanted to go. Unfortunately for me, I had already made prior commitments, notably to my wife, so better better not mess that one up. And unfortunately, I wasn't able to make this work. So, it's kind of a bummer to hear what has happened so far. And, I'm hoping that I would be able to present you with some information so that you guys would be able to see the issue a little bit better, right? So what are we going to talk about? What should we talk about actually? First of all, obviously it's a really horrible event, and really pray for the best is the only thing I can really say about this. Is let's hope for a good outcome. But in the unfortunate situation that, let's say, the worst happens, the first big thing I want to say is wait for the formal investigation to happen. Wait for the formal report to come out, because as you'll see, I guess, through the rest of this presentation, this is going to be a really complicated topic. And nobody, not one person in the world, is going to be able to just jump out and definitively say, okay, here's everything that happens. It's just not possible, right? There's so much subject matter expertise that is going to be required in order to understand what has happened to the submersible. Now, yes, you're going to see a lot of speculation, but a lot of the speculation is also based on the fact that there's a lot of noise. So what I'm hopefully going to try to do is at least eliminate some of that noise. Am I going to eliminate all the noise? Nope. Am I going to make everything crystal clear to you? No, not likely either. There's going to be a lot of uncertainty, and and again, you'll see subject matter is really complex. I'm going to, I hope, at least give you some information about what could have gone wrong. Could have been a hull issue. What about the titanium interface caps and the domes? Could have been that. What about the acrylic viewport? There's definitely some stuff about that out there right now floating about. Other components, could have been an electrical problem, right? I've got some, personal concerns about the team that was working to design and and build this particular submersible. So I want to give you that information too. But there's a bunch of things that I'm not going to discuss, and the reason for that is it's just outside my lanes, right? Operational issues, I mean, can't really talk about that. I don't really know enough about the stuff down there where the Titanic is. What is search and rescue currently capable of doing? What are the chances of survival for the people if they're still alive? I don't know. See, those are things I can't really discuss. So I'm really going to kind of stay within my lane and not really go outside of that much. And what I hope you get from this at the very end is that the issue as a whole is a super complex issue. There's so much stuff that requires really specialist knowledge in order to understand and to even interpret what possibly could have happened. And that's why I said earlier, wait for the formal report. So let's remove at least some of the noise, right? The first one is, oh my God, the game controller, right? I see this on the news. They're like, oh, it's controlled by a game controller. Well, if you ignore the craziness about what all the media is saying, just think about it this way. It's a human-machine interface, right? So you've got the submersible that requires some human input in order to get it to work. Well, the amount of stuff that you need the human to do is not overly complex. It's really directing where you want to go, forward, back, left, right, up, down, that kind of thing. So a game controller is a relatively familiar instrument for a lot of people. It's also relatively easy to grasp if you don't have a lot of experience with it, right? So it's a convenient item that will do what you want it to do, and it can provide that input interaction device sort of thing. And it works. So if it works, why not use it, right? Because you see controllers getting used all the time for a bunch of other things, and it works. So I don't really see anything really wrong with it. Now, some people might say, oh, well, it's a cheap third-party controller. Why didn't they just buy the official version? Again, for the purposes here, maybe it wasn't necessary, right? Because they're not using this to interface with like a PlayStation, which obviously would prefer an official controller. This is going to be interfacing just by providing input data. And as long as it does that, it'll be good enough. Another thing that I've seen in the news media reports is this particular statement, which came from a journalist that went on this submersible like a while back, and they had to sign a waiver, and this was on the waiver, which is this statement: this experimental vessel has not been approved or certified by any regulatory body. And I think currently the media is kind of spinning this into, okay, the submersible is just not safe and it's just not fit for people. And there's a lot of complexity with this statement. You got to kind of unpack a little bit. Notably, the major thing that I'm detecting from the interpretation of this has to do with class societies. And it's one of those things that a lot of people have a really good understanding of what they do, right? Outside the marine industry. So class societies are, you can almost think of them as being the groups, and there's a whole bunch of them depending, Lloyd's Register, DNV, ABS, etc., etc., etc. And they're really responsible for setting out a bunch of rules about, you know, how you should build something to their standards so that that thing that you build ends up being safe. But more importantly, the reason you go for class is so that whatever you're building is insurable. That means that you can actually get insurance for something. Now, that works if, let's say, you're building a big, let's say bulk carrier or something like that. You can insure that vessel with an insurance company. But what about these really highly innovative vessels? And this is where things get kind of complicated, right? If you're doing something like what this company is doing, where you're building a carbon fiber submersible that's going to take people down to the Titanic, does the class societies necessarily have the rules in place already for dealing with this kind of vessel? And if not, does that mean you've got to go through a whole separate approval process, and that's going to take many, many years? It's going to involve a lot of money. It gets complicated. And then even if you go through all that process, at the end of the day, is this particular submersible going to become an insurable vessel? And if you're not going to get insurance at the end of it anyways, it's, even somewhat rational to think, why would you go through the class society in the first place, right? There's a lot of kind of, you got to think about this a little bit, right? You really also got to think about it. Is there an issue of cost, right? From what we know so far, this company, money might have been a bit tight. So, would they have looked at the class society cost, went, oof, that's prohibitive, and at the same time, we're not necessarily going to get the benefit from it at the end? Could have been a thing, right? Again, not assigning any right, wrong, blame, or anything like that. This is merely just to say, look, you got to think about it a little bit more. There's another one, which is the 2018 lawsuit from a David Lockridge about the vessel not being safe. And if you look at the legal document, the defendant, because I think he actually got sued by the company first and then he countersued. The defendant actually argued a bunch of things. Now, one of the issues with the things that he brought up is that he wasn't an engineer. He was someone that had a lot of experience with submersibles, but he wasn't an engineer. And his issues that he brought up were engineering issues. So you can kind of see that if you're a non-engineer and you bring up a bunch of things and you demand that the engineers, let's say, give you an answer, and then you're not happy with the answer they give you, you can kind of see how that might lead to issues. Again, can't dismiss everything he said, but there's a bit of grain of salt that you got to apply to what you're reading there, right? So hopefully this at least kind of removes some of that noise and also gives you an insight into some of the things that the media has been putting out there. But what about things that could go wrong? And let's specifically talk about, I would say, within the submersible, the major components. So the first one is the hull. So from that lawsuit, by the way, Lockridge primarily expressed concern regarding the lack of non-destructive testing performed on the hull of the Titan. And this is where things get really interesting, right? Because at first you go, okay, that sounds reasonable, right? Why don't you just do non-destructive testing? And this is where I said, it's possible that because he was not an engineer, the engineer would give him an answer and he's not satisfied, so there is going to be issues there, right? Now, going straight to the class society rules, by the way, DNV is the one I consulted here, from RU Ship Part 2, Chapter 3, Non-Metallic Materials 1.1.1, it states, it shall be recognized by the production site, the yard, or the workshop that there are limited or no means for non-destructive examination of FRP structures available. So that, if you think about it, would be an indication that the employee who's not an engineer doesn't accept the answer given to them by an engineer could have caused some pretty serious conflicts there, right? And assuming that he kept pushing the issue, like, oh, this is not a safe vessel, whatnot, the company might have seen it being more of a disruptive influence and might have terminated his employment, right? Yes, of course, there was a lawsuit. They had a whole thing going on there, and both the company and the employee ended up settling, so we don't really know what the end result is. So still, you got to think about this, right? It's not like, oh, the employee, just because is the one who got fired and is the one who made a bunch of statements that the employee's all right. The company could have had some valid points as well. All right, so not really getting too much into the legal case, what about the details of the hull itself, the carbon fiber hull? One of the things, of course, is could the carbon fiber hull have failed? Was it actually designed for this depth? Because there's some reporting out there, for example, that says, hey, look, in 2020, the CEO said, oh, the hull was only rated for 3,000 meters. So, Titanic being deeper than that, this submersible couldn't reach it. Everything I've found so far seems to indicate that, no, this hull was actually designed for that. So there's an article from Composites World called Composite Submersibles Under Pressure in Deep, Deep Waters, which stated the following. So first of all, OceanGate was not the one who made the carbon fiber hull. Spencer Composites did. So they're obviously a company that has expertise in composites. And they were told to do essentially a few things, right? But to sort of, I guess, get to the gist of it, Spencer Composites did finite element analysis. They also built scale tubes, and they tested it to verify the finite element analysis results, thereby concluding that, hey, this design actually works. So what they were designing for was a surface pressure of 6,600 psi. Now, on top of this, there was a safety factor of 2.25, which means that you actually build something that is quite a few times stronger than what is actually required. So this design surface pressure and the safety factor combined, they initially calculated they needed 114 millimeter thick skin. So that's a pretty thick skin, right? But then a decision was made by OceanGate that what they were actually going to do is they were going to round it up to 127 millimeters thick. So on top of the design pressure, which is what they were going to experience down the depth, there was an additional safety factor of 2.25, and then they rounded it up more. So there's even greater factor of safety here. So most likely, the carbon fiber hull probably wasn't the one that failed. And, unless there was some sort of massive manufacturing defect or some unknown operational issue, the chance of the carbon fiber component of the hull failing seems relatively low. All right, what about the titanium components? Because that's another one, right? And on top of that, of course, there's also, hey, what about the bond between the titanium components and the carbon fiber section of the hull? Well, here's the thing. Not an expert on titanium construction used for submersibles. And therefore, I'm not going to be able to give you that insight into it. And this is the thing, right? You need someone who is a real specialist in this kind of material, used for this kind of purpose, really to kind of jump in and say, hey, I know something about this very particular kind of subject matter. I'm not that person, but there's probably like one or two things I could say, and I'll get to that in a second, right? First of all, there's no publicly available information regarding any safety concerns about this particular component, which is probably a good thing, right? Because, for the carbon fiber hull, through that lawsuit, there was concerns, but didn't see anything about this particular one. And on top of it, from the company's own releases, they did say that the submersible had strain gauges that will monitor the end caps. And from an engineering standpoint, as long as the allowable stresses is less than the yield stress, I think it should have been fine. And there shouldn't have been an issue with this component at all. Again, barring manufacturing defects, barring some catastrophic failure that we're just not aware of, just doesn't seem like this is super likely. Again, most of this seems engineered beyond, way beyond what is required and what the vessel is likely to encounter. Okay, moving on. What else could have gone wrong? Well, maybe the acrylic viewport is the possible point of failure. And there was something from the lawsuit that discussed this particular issue. So Lockridge in the lawsuit learned from the viewport manufacturer that they would only certify to a depth of 1,300 meters due to the experimental design of the viewport supplied by OceanGate, which was out of the pressure vessels for human occupancy standards. And of course, he also goes on to say that, it's because OceanGate didn't want to pay for them to certify to 4,000 meters, something like that. Well, you got to read into this one a little bit deeper, because there is one thing, of course, is, yeah, it's possible the company didn't want to pay for it, but realistically, there's something else here I think that you've got to pay attention to. And it has a lot to do with the word certify. Because certify really implies liability. Certify is saying that, a company that certifies a product is willing to be legally liable in the event that something doesn't work. And there's a possibility that the company didn't want to take that chance, right? They wanted to say, look, we're happy to certify this to 1,300 meters, which is where we have known rules and known standards. Past that, we're not willing to be legally responsible. So, since it's outside the standards, you also have to wonder, who would the certifying body even be, right? Like, if you're taking something down to 4,000 meters, who do you take it to say, hey, this is going to be something that you have to approve, and then I will say, yes, it's been certified, because it's not just something arbitrary, right? And of course, if none of these standards or whatever exists, then we've got this problem, right? We've got a problem where this is a very quote-unquote experimental viewport. So keep in mind that it is also entirely possible that if you go purely from engineering first principles or whatnot, this acrylic viewport could have actually been fine down to even way in excess of 4,000 meters. Just there was no certification authority from any kind of regulatory agency, and then the company that manufactured it also didn't want to be liable, right? And there's a very good chance that when discussing the issue of price or whatnot, that it might have been so prohibitive that, again, might not have been worth it to a certain degree, right? Remember, super experimental stuff is that. It's super experimental. There's also a statement from the CEO that, quote unquote, because it is an acrylic, you'll see it essentially before it actually fails structurally. So it'll fail optically long before it fails structurally, and in this case, catastrophically. Thus, the crew will detect a problem visually first. Take what the CEO says, as well, with a massive grain of salt. So obviously, CEO trying to make a good impression on stuff, and is it true? Not true. Unless you've got a degree of expertise on acrylic materials and how they behave in certain conditions, there's just not a real way to determine this, right? You can kind of only take things at the surface level right now and say, okay, maybe that is the case. And so if that is all true, then maybe the acrylic viewport is also not a point of failure. So if the hull, the titanium pieces, and the acrylic viewport are not the points of failure, what else could it be? Well, the other things are, for example, electrical, right? So everything on this submersible appears to run off of electrical systems, right? And things like that. So if the electrical system fails, you'd have a pretty big problem, because you would lose propulsion, you'd lose lighting, you'd lose your communications, and none of those things are good when you're deep down in the ocean. Now, with regards to the electrical system, there's actually just no real public information. And so again, If that is at fault, we wouldn't really know until a massive investigation is done and we get a report that says, okay, here's what failed. Currently, there's not really a way to know. However, that's not to say there's nothing of concern. There does seem to me, at least, something that is a bit concerning, because there was one point in time, back in 2018, something like that, where the company hired a fresh out of school engineer as their electrical engineering lead. Which, that seems a bit wild to me. Someone who really doesn't have a lot of experience, and not only do you make them an electrical designer, you make them the lead. That seems a little odd. And there's also other concerns, which is, there's supposed to be safety systems on the submarine, but none of them seem to have worked. So kind of questionable design for the safety systems. We're not really sure either, right? Now, the team itself is another funny thing to really kind of examine, right? I know that out there in the media somewhere, there's a clip of the CEO going like, yeah, we're really only hiring like young people. We don't really want like kind of old 50-year-old white guys or whatnot. Kind of funny when you look at the team photos, right? But anyways, okay. But there are concerns about the team, right? So one of them, of course, is the fact that, they hired a newly graduated engineer, made him the electrical lead, which is kind of strange there. But the rest of the team as a whole, at times, just doesn't necessarily seem to have a lot of marine design expertise. So there's a couple more examples about that. So their most recent director of engineering, you would figure for something that's supposed to go deep underwater that you would hire, maybe a mechanical engineer, maybe a naval architectural engineer. Nope, he was a software engineer. So that was a bit of a question mark for me. The previous director of engineering was a former US Navy deep sea diver. He then worked on installing and certifying hyperbaric medicine facilities, and listed as designed and installed certified systems under regulations requirements of Nuclear Regulatory Commission, the FDA, NAVSEA Systems Command, NASA, FAA. It seems like they're a little bit light on the marine design side. They also hired an engineering project manager who was a recent graduate of an oceanography program. So if there's concerns for me, this would kind of be it. I'm just a little concerned about their team, right? Because you'd kind of wanted to see more people, let's say, with more expertise in the environment that they're operating in terms of design expertise, right? And they seemed a little light on that. Again, wasn't really sure what the driving force was behind a lot of their hiring decisions. So again, any incident usually is a confluence of factors. So could this have played a role? It's certainly something to think about, I would say. All right, so moving on to things that are outside my lane, I'll kind of mention them in passing, just something for you to really kind of think about some more, right? Because realistically speaking, there's just tons of stuff that I don't understand and I'm not qualified to speak of. So just examples off the top of my head, the use of a tether versus no tether. So nothing to connect the submersible to the support vessel. There's no backup submersible. Bolting from the outside versus the inside. Why no locator beacon? Was there a reason for that? Was there just because there was no commercial beacon that they could use? ROVs on the mothership. Why are there no ROVs that could immediately get down there to see what's going on? Search and rescue capabilities. Completely outside my knowledge field, right? Possible rescue, I mentioned this earlier. And there's just tons and tons and tons more. And this is why it's best, if this actually turns into a disaster and there's a whole investigation that happens, it's best to wait for the report. Because in order to understand everything, you'd probably need subject matter experts from all types of different things, right? Human factors, material sciences, deep sea experts, etc. Tons. So hopefully by now, after going through all of this, you'll understand what I mean by things being incredibly complex. and will require time to unravel. Realistically, the best thing that all of us can do right now is just praying for the best. And that's all we can do. So, anyways, folks. Yeah, a little bit of a sad incident, and but hopefully an interesting one that you've at least maybe learned a little bit from. And of course, you know, let me know your thoughts, your comments in the comment section below. Aside from all that, folks, take care, have yourselves a good one, and I'll talk to all of you again next time.